My dear students, in the today's session, I am going to teach you about the semi-solid dosage formulations. One of those formulations is ointments. What are ointments? Ointments are semi-solid dosage formulations meant for application to the skin or mucous membrane, and it is having one or more number of medicaments. The medicament may be in the dissolved form, that means medicament is soluble in the ointment base, or emulsified form or suspended form. It may or may not contain antimicrobial preservative. Okay, this is about the ointment. What are the other semi-solid dosage formulations? That is pastes, creams and jellies. Pastes are very hard and stiff because they contain high amounts of finely divided solids, up to about some 50% solids present in the paste. What are those solids? Like calcium carbonate, zinc oxide and starch. That's why pastes are very hard when compared to the ointments. Creams. Creams are semi-solid viscous emulsions. Whenever you say emulsion, it is of two types, O by W and W by O. Oil in water and water in oil. Oil in water, semi-solid emulsion is called as the aqueous cream because water quantity is more. And W by O, water in oil, semi-solid emulsion, it is called as the oily cream. Jellies are translucent or transparent masses applied to the skin or mucous membrane. These are various types of the semi-solid dosage formulations. Now let's come to the ointments. I told you the definition of the ointment. Now, what are the different types of the ointments? It may be medicated or non-medicated. Non-medicated, it may be serving the purpose of the emollient. What is emollient? Which keeps the skin in the smooth condition. Lubricant and protectant. Medicated, depending upon the medicament used, it is having its own therapeutic activity. And what are the various ointment bases? Oleaginous bases, absorption bases, emulsion or water miscible bases and water soluble bases. The other name for oleaginous bases is the hydrocarbon bases. Soft paraffin, liquid paraffin, hard paraffin are the examples of the hydrocarbon bases, otherwise called as oleaginous bases. Absorption bases. When compared to the oleaginous bases, they absorb more amount of water. Okay? Absorption bases, example, wool fat, wool alcohol and beeswax. Wool fat is otherwise called as the lanolin. We have anhydrous lanolin and hydrous lanolin. Okay? And emulsion are water miscible bases. Example, emulsifying ointment, cetramide emulsifying ointment and cetramide emulsifying ointment. Water soluble bases. Example, PEG, polyethylene glycol. Depending upon the molecular weight, it may be in the solid form, semi-solid form or liquid form. PEG 200, 400, 600, they are all in the liquid form. PEG 1500 is the viscous liquid. PEG 1540, almost like a semi-solid. PEG 2000, 4000, 6000, all these are in the solid form. Like this, we have various PEG bases under the water soluble bases. These are the various bases. Which base we have to use depending upon the purpose. We want only superficial action, use only oleaginous bases. Only for superficial action, there is no penetration. Penetration is very, very poor. Even absorption capacity of the water or any aqueous vehicle is very, very poor. Just only 5% is absorbing here. Absorption bases, we have number of example like beeswax is there, wool fat, wool alcohol. Depending upon the need, depending upon the solubility of the drug, depending upon the penetration power, we have to use different types of the bases. What are the factors influencing the selection of the base? What are the four bases? Hydrocarbon, otherwise called as oleaginous bases, absorption bases, emulsion bases, otherwise called as water miscible bases, and fourth one, water soluble bases. Which base we have to use it? depending upon the drug, depending upon the need. We have to choose the base. What are the factors influencing the selection of the base? Desired release rate. You want fast release or slow release of the drug from the base. Topical or subcutaneous. Only for topical application or applying to the mucous membrane also. Sometimes you are doing it. In such a case, what base you have to use it? Stability while storage for long periods and at the process of the sterilization. For example, you are making some eye ointment. We are using some soft paraffin. We have to sterilize that one. So at the temperatures of sterilization, it should be stable. Occlusion of the moisture. Moisture has to be blocked by the ointment base. Sometimes it's not required on the cases now. Okay. And effect of the drug on consistency. Suppose if we are adding more amount of the drug, it may affect the consistency. For example, sulfur ointment is there. It is having about 10% weight by weight. So it may affect the consistency of the base. Removal from the skin. Easily removal or you want a fast removal. All these things are. For example, you are using some water soluble bases like PEG. We can remove it easily. If you are using the hydrocarbon bases, hard paraffin, soft paraffin, it is difficult to remove. Then why do you use it? If you are using the hydrocarbon bases, we can prolong the period of contact between the skin and ointment base and the drug. So in such cases, we have to use the hydrocarbon bases only. And surface, which part of the body are applying? Depending upon the area of the skin, the thickness varies. For example, in the palm or in the sole, the thickness of the skin is about 0.8 mm. In the eyelids, in some other areas, 0.2 mm. In some parts of the body, sweating is more. So depending upon the need, depending upon the part applied, you have to choose the base. Properties of the ideal ointment base. It is governed by the release rate of the drug at the site of application and low sensitization index should not be retained to the skin or mucous membrane. So we want low sensitivity towards the skin or mucous membrane. Elegant, pharmaceutically elegant, non-dehydrating. That means should not dehydrate from the skin. Suppose it dehydrates, what will happen? It becomes flakes, it becomes solid particles. Only we applied the ointment after some time because of the high temperature in the summer vacation, summer period. It is completely dehydrating and it is becoming like particles. So such we don't want. Okay? Non-dehydrating, non-greasy. If you are applying the hydrocarbon basis, it is greasy only. If you are applying the PEG basis, it is not greasy. Depending upon the need, you have to choose it. Neutral, should not influence the effect of the drug. Compatibility with the drug and other ingredients of the ointment formulation. No physical or chemical incompatibility or therapeutic incompatibility. Water washable, this is possible only with the water miscible basis and water soluble basis. Stability during long storage and at the same time temperatures of the sterilization. Dry heat, moist heat, depending upon the need we use these techniques. We cannot have ideal ointment base for all ointments. It's not possible because if we want to prolong the contact between the skin and mucous membrane, between the skin and the medicament, then we want hydrocarbon bases. We want easily washable, we have to use PEG base. Depending upon the need, we have to change it. There are 4 types of ointment bases. Hydrocarbon bases, otherwise called as oleaginous bases. Absorption bases. Water miscible or emulsion bases. And the 4th one, water soluble bases. The first one, we'll see it now. What is that? Oleaginous, otherwise called as the hydrocarbon bases. Okay. But there are some disadvantages or some properties we can say about this oleaginous bases. It is not absorbed by the skin. Water completely moisture occludes, the sweat occludes in the base. So it's some uncomfortable feel we used to have it. It retains the body heat. So wherever you apply, we feel some warm appearance. And suitable for emollient and protectant purpose. Emollient means which keeps the skin in the smooth condition, which softens the skin, and we can use for the protecting purpose also. And it is water immiscible. It absorbs maximum 5 to 10% of the aqueous solution, not more than that. Inert, there is no chemical incompatibility with other ingredients in the formulation. Low water absorption, that means up to 5 to 10% of the aqueous medicament solution can be absorbed, not more than that, right? In other cases like PEG bases are there, we can absorb more. That is in the last one, water miscible, water soluble bases. Right. What are the various bases under the hydrocarbon bases, or I can say oleaginous bases? Mainly there are 3 types. 3. Liquid paraffin, hard paraffin, soft paraffin. 3 bases under the oleaginous bases. Soft paraffin. Soft paraffin is available in 2 forms in the market. Yellow soft paraffin and white soft paraffin. What is the difference? That we'll see it. First of all, what is soft paraffin? It is a mixture of semi-solid hydrocarbons. Obtained from petroleum or heavy lubricating oil, like shale oil, right? Shale oil. And it is a crystalline matrix embedded in a colloidal gel. It looks like that, right? Now, soft paraffin, the melting point is 38 to 56. You have to remember these melting points, because in the preparation of ointments, which ingredient we have to add, to find out that we should know the melting points, right? And it is available in 2 forms, yellow soft paraffin and white soft paraffin. What is the difference? Basically, we have yellow soft paraffin only, but by some suitable treatment with some bleaching agents, bleaching agents like some acids, oxidizing agents, we can prepare the white soft paraffin. By a bleaching treatment of the yellow soft paraffin, we can get the white soft paraffin. So white soft paraffin may have some trace amounts of the bleaching agents. So if you are using this white soft paraffin, the preparation of the eye ointments, it may cause irritation to the eye. So don't use white soft paraffin in the preparation of the eye ointment. Use only yellow soft paraffin. White soft paraffin may have trace amounts of the bleaching agents. Okay? And eye ointments are prepared only with the yellow soft paraffin. Okay? Now, suppose this soft paraffin is not available. We can go for some alternative, that is some substitute. We can prepare by using the 5% polyethylene. 5% polyethylene in liquid paraffin at a temperature of 130 degrees centigrade. We can prepare this soft paraffin substitute also. So next one, hard paraffin. Hard paraffin. What is soft paraffin? Is a semi-solid hydrocarbons. Soft paraffin, semi-solid hydrocarbons obtained from petroleum. Hard paraffin, solid hydrocarbons obtained from petroleum or heavy lubricating oil like shale oil. Hard paraffin, solid hydrocarbons. Soft paraffin, semi-solid hydrocarbons. Liquid paraffin, liquid hydrocarbons. Okay? Hard paraffin is a translucent wax in between the opaque and transparent. Translucent wax-like substances. Melting point is 50 to 57 degrees centigrade. Melting point of the hard paraffin 50 to 57. Soft paraffin 38 to 56. Broad range is there. Hard paraffin maximum 57 only. 50 to 57 only. Next one. And this is hard paraffin. For what purpose we use? To stiffen the ointment, to increase the consistency of the ointments, we can use the hard paraffin. Suppose this is not available, we can use it as a substitute. Cosmoloids can be used as substitute. If we are using the cosmoloids instead of the hard paraffin, we can minimize, we can reduce the tailing effect. What is the tailing effect? You take some ointment. Generally, you are using the paste in the morning. When you apply the paste, there is some tailing effect sometimes. So what is that tailing effect? This is applied here on the skin. It comes like a tail like this. It comes like a tail. The tailing effect can be reduced by using cosmoloids instead of hard paraffin as a substitute. Right? Next, liquid paraffin. Liquid paraffin is a mixture of liquid hydrocarbons obtained from petroleum or heavy lubricating oil. And it is, when you are using for a long storage, when you store for long periods, what will happen? There is a possibility for the oxidation. So we have to add some antioxidants like tocopherol or BHT. BHT, butylated hydroxytoluene, at a strength of 10 parts per million. 10 parts per million, we are using the antioxidants to store the liquid paraffin for long periods. And generally, liquid paraffin is used in the eye ointments also. Basically, we use the soft paraffin in the preparation of the eye ointment. 25% of the soft paraffin substitute with the liquid paraffin so that it is having some consistency. It is easily coming out from the eye ointment nozzle. Okay, so to increase the extrusion capacity from the nozzle, we can substitute 25% of the yellow soft paraffin with the liquid paraffin. So these are the various hydrocarbon, or I can say oleaginous bases. After hydrocarbon bases, the next important one is the absorption basis. Is the one more type of the base in the preparation of the ointments. Absorption bases. The best examples: wool fat, wool alcohol, and beeswax. Okay. What are the absorption bases? Absorption, they absorb water. Right? Depending upon the type, wool fat is there. We have the hydrous and anhydrous wool fat. Wool fat is otherwise called as the lanolin. Anhydrous wool fat can absorb water or aqueous preparation up to 50%. Hydrous wool fat already contains 30% of the moisture. Right. It absorbs moisture and it forms the water in oil emulsions. It forms the water in oil emulsions. Remember, this point is a very important point. We'll discuss it again later on. Right? It consists of, what is that absorption basis? It consists of the sterol containing substances. Sterol containing substances. And it is having some ease of spreadability comparatively when compared to the other bases. Easily we can spread it. And it is having some good emollient property. What is emollient? Which softens the skin, which soothes the skin. And it assists the penetration of the oil soluble ingredients or medicaments through the skin. It assists the penetration of the oil soluble medicaments through the skin. And the best example of the absorption basis, wool fat. Wool fat. Okay. What is that wool fat? It is a fatty acid esters. Fatty acid esters of cholesterol and other sterols and fatty alcohols. Remember this one, wool fat is very important. Even for the Viva point of view, also common question in the Viva examination. What is the other name for wool fat? Lanolin. What is wool fat? It contains fatty acid esters of cholesterol and other sterols and fatty alcohols. And melting point of the wool fat 36 to 42 degrees centigrade. And is sticky comparatively. And as I told you, wool fat is otherwise called as lanolin. Available in two forms, hydrous and anhydrous. Anhydrous lanolin absorbs water or any aqueous preparation up to 50%. 50%. Hydrous lanolin contains 30% of water. These are the two. In the common question, in the Viva, what is the amount of moisture or water present in the hydrous lanolin, hydrous wool fat? That is 30%. How much amount of the water can be absorbed by the anhydrous lanolin is 50%, right? And here wool fat, there is a possibility of the oxidation while storing for long periods. While it is oxidized, it becomes discoloration. There is a possibility for the surface discoloration, change of color in the surface. Right? To prevent this one, we have to add the anti-oxidizing agents, antioxidants, like butylated hydroxyanisole or butylated hydroxytoluene at a strength of 200 parts per million, 200 ppm, 200 parts per million. And this wool fat, we can alter the properties by suitable treatment like hydrogenation, fractionation, or treatment with the ethylene oxide. By hydrogenation, we can make the preparation non-sticky so that we can improve the spreading property also. By fractionation, we can make it non-sticky and it is viscous also. We can use in the stabilization of other preparations. Stabilization purpose. And the most important one, just remember this one, this wool fat on treatment with the ethylene oxide, it forms the polyoxyethylene derivatives. Polyoxyethylene derivatives. Wool fat is helpful in the preparation of W by O emulsions. Wool fat by treatment with the ethylene oxide, we can make it O by W emulsifier. Wool fat basically we can make in the preparation of W by O emulsions. But on treatment with the ethylene oxide, we can convert into the polyoxyethylene derivatives which are useful in the preparation of the O by W emulsions. Okay? And this wool fat, lanolin, we can use in the preparation of the simple ointment at a strength of 5%. In the preparation of the eye ointment, ophthalmic ointment, we can use at a strength of 10%. What is the composition of the eye ointments? Yellow soft paraffin up to about some 80%, liquid paraffin about 10%, and wool fat 10%. I told you in the previous part, that is yellow soft paraffin 80% is there. 25% of this we can substitute with the liquid paraffin so that from nozzle the ointment can come out easily because you have to apply to the eye. So it has to come out easily. For easy spreading, for easy extruding from the nozzle, we can replace a part of the yellow soft paraffin with the liquid paraffin. Absorption basis, I said wool fat. The next one is the wool alcohol and beeswax. What is wool alcohol? It is obtained by the crude fractionation of wool fat. The previous one, lanolin, and making some fractionation of the wool fat, we can get the wool alcohol. Wool alcohol melting point is 58 degrees centigrade. 58 degrees centigrade. And it contains cholesterol up to about some 30% and along with the other alcohols. And protect from the light is the photosensitivity preparation. So a small amount up to about some 2.5%, 2.5% stabilizes the O/W emulsions. Okay. Next one is the beeswax. It contains the myricil palmitate. Myricil palmitate is an ester of higher fatty alcohol. Beeswax is available both in the yellow form and white form also. Yellow beeswax and white beeswax both are available. Right? And it contains the small amounts of the cholesterol. And the important point here you have to remember, that is, it contains the cerotic acid. C25H51COOH. This is useful in the preparation of the cold cream. Cold cream composition contains the beeswax and borax also. What is borax? Sodium borate. Sodium borate reacts with the cerotic acid of the beeswax. Sodium borate reacts with the cerotic acid of the beeswax and it forms the emulsifying agent, which is helpful to prepare the cold creams. So this is about the beeswax and wool alcohol. Emulsion basis, maybe O by W type or W by O type. Oil in water type, water in oil type. Here, aqueous phase in O by W, water is the continuous phase. Aqueous phase hydrates the skin, and oily phase, it forms an occlusive coat over the skin and it prevents the loss of water from the skin, loss of moisture from the skin. An example, O by W emulsion base, and which is a hydrophilic ointment. Example, vanishing cream. Vanishing cream is a type of cream which is completely aqueous cream. It contains the triethanolamine and stearic acid. It forms the triethanolamine stearate in situ. During the preparation, it forms the emulsifying base. And other examples, we can use the non-ionic surfactant for the purpose of the emulsification. We'll see the examples now. What are the official anhydrous water miscible bases? Otherwise called as emulsion base, otherwise called as the water miscible base. Emulsifying ointment is anionic in nature, and cetrimide emulsifying ointment is cationic in nature. Cationic in nature. Citalmacragol emulsifying ointment is the non-ionic. So we have all types here. Advantages of this water miscible, or you can say water miscible or emulsion bases. Miscible with the exudates. It may be sweat, or it may be some sebum, or it may be something, any exudate from the skin. It is completely mixing. And so that here advantage is the ease of removal from the hair. You are applying some cream here. You are applying some cream here. It has to be removed easily. Some hair is there. Wherever hair is there, generally it is difficult to remove some moisture or sebum, all these things. So if you are using this emulsion base, we can easily remove this emulsion base from the hair by suitable, just water washable, water miscible only. And interference is reduced with the skin functions. Reduced interference with the skin functions and good contact with the skin because it is having surfactant, and high cosmetic acceptability. That is the emulsion base. Next one is the water soluble base. The next one is the water soluble bases. The best example, macragol, polyethylene glycols. This is the formula: CH2OH, CH2O, CH2, N number, and CH2. Depending upon the number, N is equal to some number. Depending upon that, PEG may be varying from 200 to 10,000 also. Okay. Now, PEG, what is macragol? It's a mixture of the polycondensation products of ethylene oxide and water. Polycondensation product of ethylene oxide and water. Depending upon the molecular weight, it may be in the liquid form, semi-solid form, or solid form. PEG 200, 400, 600 in the liquid form. What is that number? Approximate average molecular weight. Semi-solid PEG 1500. Solid PEG 1540, PEG 2000, PEG 4000, PEG 6000 in the solid form. In the preparation of some ointments, sometimes you have to sterilize this ointment depending upon the need. You are applying some eye, applying to the eye, or somewhere you need some sterile preparation. In such a case, liquid PEG can be sterilized by using the autoclave. Solid PEG sterilization by using the dry heat, hot air oven technique. Autoclave at a temperature of 121 degrees centigrade and at a pressure of 15 pounds per square inch and for a period of 15 minutes. Dry heat, hot air oven at a temperature of 160 for a period of 1 hour for the purpose of killing the microorganisms by the process of sterilization. These macragols are non-toxic, non-irritant and non-greasy also. Earlier, There are some sticky, greasy, so many bases we have studied earlier. Now this is non-greasy, non-toxic also. If you make a solution of macrogol at a strength of 5%, the pH may be varying from 4 to 7.5. Its best advantage is compatible with many medicaments like ictamol, phenol, and ammoniated mercuric oxide. Like this we have number of medicaments. It is compatible with all those ingredients, but it's not for all. There is some incompatibility with some drugs like penicillin and bacitracin. Okay, we'll see it later on. Compatible with ictamol, phenol, and yellow mercuric oxide. Remember that one. Advantages of the water soluble bases, that is macrogols or PEG. Water solubility is more. Right? Good absorption capacity. It absorbs the moisture. Good solvent properties. It dissolves many aqueous preparations. And satisfactory aging properties. Suppose there is a liquid paraffin, there is a problem of the oxidation. But here such a problem is not there. Good aging properties. And disadvantage is also a very important point here. Less bland. What is that blandness? Blandness means spreading property. Spreading property is less for the PEG. Less bland when compared to the paraffins. And reduction in the activity of the phenols, quaternary ammonium compounds, and parabens. What is paraben? Para-hydroxybenzoic acid. Butyl paraben means butyl para-hydroxybenzoic acid. Para-hydroxybenzoic acid, simply called as the paraben. Inactivation of the penicillin and bacitracin. So compatible with the ictamol, but incompatible with the penicillin and bacitracin. And solvent action, we have studied earlier, solvent properties, solvent action in the polyethylene and bakelite. Some of the containers made of the polythene or bakelite. This PEG is having some solvent action on the polythene container, and after a few days there is a possibility for the leakage of the drug solution from the polythene containers. These are the advantages, disadvantages of the water soluble bases, that is macrogols. This is about the ointments and various bases in the preparation of the ointments.